Okay, here's another quick supplemental lecture on a topic related to IP version 4 addressing. And this is basically an example or a discussion of a type of problem that I will be putting on your homework, possibly an exam. And that is, given an IP address and subnet mask, is this IP a host address, a network number, or a broadcast address? So this is an example of a problem that I might give that we're going to work through, and that is you're given the IP 192.168.0.10 and it has a /27 subnet. And is this a network number, a host address, or a broadcast address? So it's probably be better if this was interactive, in-person type thing, but if I'm discussing this in the classroom, what I would do is ask, what is the first thing we need to do? And hopefully you would come back, since this should be review from 160, 161. We need to figure out where the division point is between the network portion of the IP address and the host portion of the IP address. So how do we divide the IP into this network and host portion? And the correct answer to that is we apply the net mask to the IP. So another way to say that is we do a bitwise AND of the IP address and the subnet mask together. So when we go through and do this, do we really have to convert the whole IP address to binary, then convert the whole subnet mask into binary, do a bitwise and then convert it back to get the network number? And the answer is no. And the reason for that is if we AND anything with a 1, we get that anything back. So 0 and 1 is 0, 1 and 1 is 1 if we look at our AND truth table. The other fact is if we AND anything with 0, we're going to get 0. So where you have 255s or all 1s in an octet, you're just going to get that octet back. Anywhere you have all 0s in the subnet mask, you're going to get a 0 in that octet. So the answer to this question is no. We just need to worry about the octet where this division point is. So if we go through and look at /27, we start out in decimal 255.255.255. In a /27, the division point occurs in the 4th octet. So we need to break that out in binary. So 1, 1, 1, 0, 0, 0, 0, 0. So that's what I mean by we only have to deal with that octet in which the division point occurs. Now then, if we look at the IP address we were given, is 192.168.0.10. So we need to convert that 10 to binary, which is 00, 00, 10, 10. So what that tells us, one thing I often ask is what is one of the conditions or things we can say about a subnet mask to verify that it's valid. And basically a subnet mask is a whole bunch of 1s followed by a whole bunch of 0s. Where we have 1s, that is the network portion, and where we have 0s, that is the host portion. So that would make our division point here, where that series of 1 ends and the series of 0s start. The next question is, what is the easiest way to tell if an address is a network number? And of course the answer to that is the network number is the first IP in a subnet, and it has all of its host bits set to 0. So looking at the top, is this true for our IP address? Are all the host bits 0? No, there's 0, 1, 0, 1, 0. So this is not true. Therefore, the IP address is not a network number. Now then, looking at the same setup, what is the easiest way to tell if an address is a broadcast address? The broadcast address is the last address in the subnet. Maybe an easier way to say that is all host bits are set to 1. So is that true for our IP? Is the last 5 bits 1, 1, 1, 1, 1? No, that's not true. They are 0, 1, 0, 1, 0. So that means we do not have a broadcast address. So if the address is not a network number and it's not a broadcast address, then it is a host address. So several important things here beyond the question, what type of address is it? And that was a refresher on the subnet mask. What makes an address a network number? What makes an address a broadcast number? So I just wanted to, like I said, review that really quickly.